Hello, class. So we are in section 10.6, which is all about determinants. All right, which we kind of had needed last section, but that's okay. All right, so you already know the determinant of a 2 by 2 because I've told you. All right, so if you have a 2 by 2, A, B, C, D, then the determinant of A, which we also write kind of like absolute value bars, okay? So if you see like absolute value bars in a matrix, that means take a determinant. Okay, so like this is AD minus BC, which if you like notice this pattern, I'm like doing like this, right? Like I multiply the diagonal and subtract the reverse diagonal. So it makes kind of this like gamma shape. Okay. So we can calculate 2 by 2 determinants, no problem. Okay, so 2, 4, negative 5, 1. The determinant of A will be 2 times 1. 2 times 1 minus negative 5 times 4, which is 2 plus 20, which is 22. Okay, so the determinant of that A is 22. Here I have 1, negative 7, 0, 3. The determinant of this is 3. Okay, because it's like 3 minus 0, which is 3. So this will kind of give you a hint that you like zeros. Zeros are very nice because they'll cancel out lots of things when you calculate determinants, okay? All right, so how do we take determinants of things bigger than a 2 by 2? Well, before that, I need you to memorize this like sign chart matrix. All right, and it just has this pattern where it's plus, minus, minus, plus. Okay, that's the 2 by 2 version. And it just always starts with the plus in this corner and then just changes signs, always. Okay. So this is the 3 by 3 version. This will be the 4 by 4 version. And there's a 5 by 5, so on and so forth. Okay, so I need this sign chart thing because what we do is we actually kind of do an expansion, okay, about a specific point, okay? So what I mean is I'm going to do the 2 by 2 determinant again, but I'm going to do it kind of like how I'm supposed to. All right. So the trick is you pick a number, any number. It does not matter. All right. So actually, I'm going to pick this 1 just to be weird. Okay. And what you do is you expand about a column or row you can pick. I'm going to pick the row. Okay. Or no, I'm going to pick the column. Okay. I'm going to pick the column. And so what happens? So this 1 will have a minus sign. So I'm going to do minus and then the 1. And then what you do is you cross out the row and column and you take the determinant of whatever's left over. Okay, so here's going to be a negative 1. Okay, and that's step 1. Then, since I said I'm going to go around the column, I circle the 3, and the 3 has a plus sign. So I'm going to do plus 3. Okay, and then I'm going to do this crossy thingy and take the determinant of this. Okay, and then if I do all of the, now I'm done. I finished the matrix. Okay. Then what I do is I just, figure what I wrote down. So this is going to be 1 plus 5, which is going to be 6. Okay. Wait, what? No, 1 plus 6, which is going to be 7. All right. And if we did the determinant the normal way, right, it would be 6 minus minus 7. So 6 plus 1 equals 7. So it works. Okay. And that's how it works. Okay. However, so now I need to do it with bigger things. Okay. So here's a 3 by 3, and here's where this will start to make sense. Okay. So 2 3, negative 1, 0, 2, 4, negative 1, 5, 2. Okay? So what I'm going to do is I'm going to pick this column, okay, and expand it. So I'm going to start with, so determinant, my bad, excuse me, determinant. Okay, so I'm going to start with the 2, and the 2 has a plus sign. So 2. Then I cross this out, and I take the determinant of the leftovers. Okay, now you see some stuff happening, okay? And that's like step 1 done. Then I do the same thing, 0, because I'm going to pick the column. So I'm going to do plus 0. Well, technically, no. 0 has a minus sign. So I should be using, I should put negative 0, even though it doesn't matter. All right, and then I cross this out, and I take the determinant of this thingy. So 3, negative 1, 2, 5. All right, and then last step, right, this negative 1. So it should be plus negative 1, determinant of the leftover. So 3, negative 1, 2, 4. All right, and that's how you do a determinant, okay? So for a 2 by 2, it's really easy because you just get like technically 1 by 1s, and the determinant of a 1 by 1 is just itself, like it's the number, okay? But when you get bigger, then you have to do like determinants inside of determinants, and it gets messy. Okay, so here's an example though of why we like 0, because since the 0 is here, I actually don't have to do any work here, right? I don't even have to find the determinant because 0. Okay, so that saves me like a third of the work I have to do. But now I have to figure out this thing's determinant. So 2, and right, this is gonna be 4 minus 20. And then I need to figure out this thing's determinant, which this is gonna be 12 plus 2. Right, so then 2 times negative 18 minus 14, which this is going to be, what is it, negative 26? No, yes, no, negative 36. 18 plus 18, yeah. Yeah, so negative 36 minus 14 is negative 50. Okay, so the determinant of A is negative 50. All right. Okay. Now, let's do another one. Okay. So a 3 by 3. Okay. Because 2 by 2s, honestly, they're pretty easy, right? So 1, 1, negative 1, negative 2, 0, 2, negative 3, 2, 3. Okay. So determinant of A. All right, so I'm gonna pick, I like 0. Okay, remember that I like 0. So I'm gonna expand this column, okay? So that means I have to look up in my memorized sign chart these signs, okay? So I'd start with negative 1, okay? Determinant of negative 2, 2, negative 3, 3, okay? Then it'd be plus 0, okay? 1, negative 1, negative 3, 3. Then it would be minus 2, one, negative 2, 2. Okay, and then I'm done. Right now I just need to figure out what I wrote down. Okay, so the 0, again, it's so nice when you have zeros, okay? So strategically pick what column or row you expand around, okay? you normally would like to pick the row and the column with the most zeros, okay? But yeah, so -1, that's gonna get you -6 plus 6, okay? -2 times, and then you're gonna go here, and that's gonna get you 2 plus 2. Oh yeah, okay. 2 minus plus 2, so 2 minus 2, all right? Which gets you -1 times 0 minus 2 times 0, which gets you 0. So the determinant of A is 0, which, you know, that's fine. But remember from last section, what does that mean? Okay, since the determinant of A is 0, that means we know A inverse does not exist, okay? This matrix has a special name. It's called singular, okay? This matrix is singular, which means it doesn't have an inverse, okay? Which is code for the determinant is not 0. All right, okay, so now, hopefully you understand this method for calculating determinant, okay? This is how you calculate determinant for 3 by 3, 4 by 4, 5 by 5, 2 by 2. This is the method, okay? Now, let me show you, okay, a secret method for calculating a 3 by 3's inverse, okay? So, let's, -50 is a little big, so let's not do that one. Let me just get this random matrix, okay? So 1, 2, 3, -1, 0, 1, -1, -2, +3. All right, so the secret way to calculate a 3 by 3's inverse, okay, that works, is what you're gonna do is you're just gonna copy and paste the first two columns. So 1, -1, -1, 2, 0, -2, okay. Then you're gonna do this whole bunch of multiplications and it's just gonna magically work, okay? So you're gonna multiply this diagonal. So 1 times 0 times 3. Then you're gonna put a plus sign. Multiply this diagonal. So 2 times 1 times -1. Then you're gonna multiply this last diagonal. Plus 3, -1, -2, okay? Then you're gonna multiply this reverse diagonal, okay? But now you put minus signs in front. So minus 2 times -1 times 3 minus 1 times 1 times -2 minus, and then the last one, 3, 0, -1. Okay, which it looks like a lot of work, but like it's pretty simple, right? Multiply, 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 multiply. You're doing like 6 multiplications, okay, and then adding them all together and subtracting, okay? So if you do all of this work, right, so we're gonna get 0, minus 2, plus 6, minus negative, so minus -6, so that's plus 6 again. Plus 2, because it's minus -2. Okay, and then 0. So plus 0. So you add all of these together, and you see that the 2's cancel. So then the answer is 12. Ta-da! The determinant of A is 12. Okay, so this is like a secret way. It only works for 3 by 3's. Okay, you cannot do this trick for a 4 by 4. All right, like if you have like a random 4 by 4, right? You can't just like copy these things over here and do the same like diagonal thing. Does not work. Okay, it will not work. Okay, it only works for 3 by 3's. All right. But it's a nice trick that I used to use all the time when I was an undergrad. Nowadays, I just do this too. Nowadays, because like zeros are nice here. They're a little less nice here. But yeah, so that's a secret way to do a 3x3 determinant. Okay, that's nice. Let's do one more. Okay. Then let's do a 4x4. Okay. So this one would be normally very bad. Okay. But I'm gonna pick something very specific. No, I should not do that. Put a minus sign here. Yeah, okay, there we're good. Okay. Okay. So normally this would be horrible, right? This would take a lot of work. Okay. But remember, you can strategically pick what column or row to expand around. So obviously you should pick column 3 because it has 3 zeros. Okay. So what does that mean? So first of all, remember plus minus plus plus minus plus. So that's going to give the determinant of this 4x4, okay, is going to be plus 1, right? And then I'm going to cross this out, and then I have to take this thing's determinant. So 1, negative 1, negative 1, negative 1, and negative 1, 2, negative 1. Okay. And then all of the other things are 0, right? So that's the niceness of having lots of zeros, okay? Is that they will literally save you 75 to 25 to 50% of all effort required. Okay. So really, the determinant of this 4x4, I could do it just by doing this, which is really just a determinant of a 3x3. Okay. And then I'm gonna do this like cheating way that I just showed you. So negative 1, 1, negative 1. All right. So that's minus 1 plus 2 plus 1. That's 3 negative signs, which is negative 1, but minus negative 1 is going to get me a plus 1. Minus 2, well, minus negative 2, so that's going to be plus 2. And then minus negative 1 is going to be a plus 1. So the answer is, so that cancels. So the answer is 4 plus 2, so the answer is 6. Okay, the determinant of this 4x4 is 6. All right, so not that bad. Okay, again, just the power of having lots of zeros. All right, so now that's half of the section. The other half of the section is a thing called Cramer's rule, which is something that really only is ever taught in this class. But it's really nice, okay? So what this says, okay, is if you have a system, okay? So, right, a system of equations, right? We solve these by multiplying by D inverse, right, on both sides. And getting a B, right? So X equals D inverse B. That's how we normally solve these, okay? Cramer's rule is a different way to solve these, okay? So what this will have you do, okay, is first of all, remember, right, we still need the determinant not to be 0, okay? So the determinant of D cannot be 0 because it doesn't matter what you do. If the determinant of the matrix is 0, there's no solution. So you can't get answers, okay? But actually, the answers, so like X, comma, Y, comma, Z, comma, right, all your variables, okay, they're gonna be D, the determinant of the matrix that we're gonna call DX over the determinant of D. And it just keeps going. So dy over D, comma, Z equals DZ, DZ over determinant D, right? So on. Okay, so this is nice because I think most of us agree that finding determinants, even even though they're a little complicated, finding determinants is way nicer than putting a matrix into reduced row echelon form. Okay, So let's have this system. Okay, let me just show you by example how to do Cramer's rule. Okay, so I'm gonna do it with a 2x2 because it's, nice. So here I have a system. All right, and remember, in matrix equation land, it is this system, or this equation, -1, 2. All right, so Cramer's rule just tells you the answer, right? X is equal to dx over d. What is dx, though? Okay, so we know d is just 2,618. Dx, okay, is you replace, okay, the x column, which is the first one, right? You replace that with the answer column, which is the thing on the right-hand side, okay? So 6, 8. All right, and then you just calculate this, and it magically is the answer, okay? So, what do you get? You get -8 minus 12 over 16 minus 6. So you get -20 over 10. So the answer is -2. Ta-da! So that's really nice, right? And then same thing. If you want y, it's the determinant of dy over d. We already know the determinant of d, so I'm just going to put the 10 here. Okay, that's nice. Dy, right, is going to be, so 2, 1. And now I have to replace the y column, okay, with the answer slot. That red. All right, so this is what gets me dy, which, right, so that's going to be 4 plus 1, so 5. So 1/2. And ta-da, that's the answer, right? The answer, x equals -2, y equals 1/2. Okay, so Cramer's rule is really nice. It's just that everyone forgets it exists, honestly. But it's good. Okay, it solves problems. So let's do one example of a 3x3 system, okay, using Cramer's rule. So 2x minus 3y plus 4z equals 1. X plus 6z equals 0, which I don't like that. Let's put the yeah. And then 3x minus 2y equals 5. Right? So the matrix equation would be this, right? 1, 0, 6, 3, -2, 0. X, Y, Z equals 1, 0, 5. Okay. So first of all, we're going to find the determinant of D because we need to use that 3 times. So might as well find that one first. Okay, so D is -3, 4, 1, 0, 6, 3, -2, 0. Okay. I'm going to do it I'm going to do it the normal way, actually. So I'm going to expand around row 2. Okay, so I'm going to pick this row and do the expansions. So 1. So wait, okay. So remember, plus, minus. Okay, so it should be -1. Okay, from the sign chart thing. So -1, determinant, -3, 4, -2, 0. Okay, 0, because, right, like the 0. Okay, so I don't care. So minus, plus, minus. So -6, determinant 2, -3, 3, -2. Okay. So the determinant of D is going to be negative +8. So -8. and then minus, so that's gonna be -4 plus 9, so -8 minus 5, which that gets you -13. Okay. Um, I forgot the 6. Okay, I was like, this feels a little wrong. Okay, yeah, don't forget the 6. So -6. Okay, so -8 minus 6 times, that's 5. So -8 minus 30, which is -38, and that is correct. Okay, all right. So the determinant of D is -38. All right. Okay, now, just keep going. Okay, so what's x? X is dx over d. Determinants, right? So I know this is going to be -38. The determinant of d, though, so let me like write it a little normally. 1 over -38. And then I need to figure out what the x is. So, right, since this is the x, I'm going to put this in the x column. And then I need to, everything else stays the same. All right, and now you really see that you should expand around row 2, right? So -6 over -38. So that negatives are going to cancel. Determinant 1, -3, 5, -2. So -6 over 38, which actually I should just, oh wait, no, positive. So 3 divided by, what's 38 divided by 2? That's 4. But no, wait, no. So 30 divided by 2, 15. What is this number? It escapes me. 38 divided by 2. 1. This gets you 19. There we go. All right. And then -2 plus 15. So 3 times 13 over 19. Which is, that's a weird number. So x equals 39 over 19. All right. We could do y. How much time? Oh yeah, we have time. All right. So dy over d. So we know this is gonna be here. So dy. So 213, 105. Okay, because this is the special column. Okay. And then 460. Okay. I'm gonna choose to do this the cheating way, actually. So 0, that's 18. That's 20. That's 0. Minus, okay, that's a big number. Minus 30, so -60. -60. 0. So actually, it's not that bad. So 18. So this is gonna give me -40. So -22. Okay. Yeah. Okay. So yeah, y is -22. Oh, wait, why is negative 22 divided by negative 38? Okay, so answer, y equals negative plus, so plus, right? 22 over 38, which divide everything by 2 is 11 over 19. All right, a little better. All right, and then the last one, dz over d. This is negative 1 divided by 38. 105, 213. What's the original? 3, negative 0, negative 2. Yes, okay. All right. Here, it'd be smart to pick this expansion, right? So negative 1 over negative 38, so that cancels. Determinant of negative 3, 1, negative 2, 5. So this is going to equal 1 over 38, negative 15 plus 2, which is negative 13 over 38, which that's actually stuck that way. So there you go. All right. Y is this, X is this, Z is this. All right, a little messy, but that's Cramer's rule. Feel free to use Cramer's rule. All right, Cramer's rule is nice. I like Cramer's rule. If you hate Cramer's rule, feel free to never use Cramer's rule, unless I literally force you to. Like, right, if the question says solve this using Cramer's rule, you should do that. But this is the determinant section. All right, it's a little shorter, hopefully, but that's it for this section. All right, see you guys next.